Wednesday is your test. As I said, I think just about everybody has had me before. But the test is open all day on Wednesday. Once you start it, you have to finish it, and it's timed. But if you're a morning person, that works out great for you. If you're an afternoon person, if you're an evening person, if you're a person with scheduling problems, etc., 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 it works the whole day. You will be recorded with the cameras. I just went in and looked at 161, and anytime your face goes out, it marks it and so on. So I get to see who the students that possibly might be cheating on, et cetera, who's talking, all of that's kind of really cool what they've done with all of that. But Sophia always likes to know 33 multiple choice, 7 short answers. It's on the first 6 weeks, week 1 through 6 of class. Does not include exceptions, and templates. Moving right along, exceptions. First thing we're going to talk about today. Exceptions. It's when an error occurs and something happens. Normally, when an error occurs, our program just crashes. So, what we're going to start out with briefly talking about that you've got out of the video is these exceptions, but you will also see them in 230. You will cover Java exceptions, and they're a little different way to do some of the things you want to do. But for us, we get in here, and an exception is something that can be thrown, and if it's not caught, it's caught by default by C++, and an error message is created. As you watched, we were putting these exceptions in try constructs. I usually say try blocks all the time. And we can actually catch the error so that we can say, oh, this is what you did wrong, and possibly make the program continue without crashing. So some people have come into classes with try and catch. They put them in, and I'm like, not yet, not yet. And then their programs get all messed up. I'm like, okay, but now you have an introductory idea of what's going on. We in the Gaddis book in the video, we took a look at a couple of different ones. And when we throw an error occurs, like dividing I don't know what it is, the error needs to be caught. And where we're catching them in is this throw negative size error, and it's actually going to be caught in a class. And as you looked at these versions and watched the videos, you saw that we can have one exception class. We could have multiple exception classes. And early on, these were just empty. And when you got to version 3, you saw that once I catch the error, there's a whole lot of stuff I can do. I can get into an explanation of what's wrong. For example, if I throw an error and I make up my own. There's users and then there's ones that are included in C++. But if you're making up your own, you could throw a bad piece of data and say inside the body of this exception class, hey, you're not allowed to enter a negative, or hey, the total is over 100, or lots of different things. So from the video, hopefully you watched it, do you have any questions about what was going on with these exceptions? How we handled the exception? Where we went to by creating an exception class? And at the end of this video, there was a, hey, I'd like you to try it on your own now version where you went and created an exception class. Okay, there was a practice program. Now, I didn't get any questions about it. Do we have to do it? Don't we have to do it? That's again, that's a practice program. You want to get good at what you read, what you watched in a video that wasn't 75 minutes long, so there was time available. for you to go and practice that program. If you do it and upload it, that's fantastic. Do I like seeing students who upload things? Absolutely. Does that help out down the road? Well, one, it's going to help you on the test. Two, it just helps you be identified as a good student, like posting programs, participating in class, on and on and on. Are there any questions on exceptions? Any at all? Okay. It's always interesting that I find students either got all this or they have no idea what I'm talking about at this point. And they go, oh crap, I need to get back in the book and figure out how to do this. Okay, templates. We have the skinny template and then we have the big template. Why am I crooked? We have the skinny template. And not this test, but the following test, test number 2, this is going to be on it. And you need to know what it is. And it's actually pretty cool. A template, I should throw the word in here, is generic data type usage. What are you talking about? Well, from the video, you should have seen how we can create in this case, a function. Here's 2 functions that are generic. And generic data type, meaning I don't need to know what the data type is. I can write a function. This guy is a function where I don't need to know any of the data types inside of here. So what do I need to do in order to have a template? I need to start out with this line, template, angle braces, class T. Now that just says, okay, I'm getting ready to do a nice little function. When I looked at this function, you notice the return type was T. The function name was square. The data type was T. So whatever I pass in, for example, if I pass in an integer, T says, uh-oh, we're dealing with integers, integer coming in, integer being returned. I'm working with all integers inside of here. If I call square and I pass in a double, square, and I pass in a double, this better be assigned to dub num, some sort of double. Because what's coming in has to be the same as what's going back out. That's not very good. I ran out of room there. I'm going to do this. Num is a double, wrong order, but num. If I send a num in, a num has to come back out. Here's another look at a template. This one's kind of cool. Why? Start out with template class T. I have a void method, a void function. The function name is swap bars. I have a reference variable coming in of a data type, and I have a reference variable coming in of the same data type. And I create a local variable also of that same data type. And what happens? I do a nice swap of 2 items. I can swap integers, I can swap doubles, I can swap whatever, whatever, whatever. Brings in its data type. And then there were more examples, the in-depthness of watching the video, where these T's could be different. I could have more than one T, I could have more than one generic data type coming in. And one of the examples you should have seen was the size of a var. What's the size of var1? I could tell if this was an integer or a double because the size of function would help me out with that. Something that was in the video as well. Booleans. So that was functions. If that was all chapter 6 in Gaddis. If I got ready and went to chapter 17, you see the standard template library. And in a small nutshell, it's making the whole program a template, meaning you don't need to have a data type coming in. So a bunch of stuff you've been seeing in the last few chapters, and we haven't covered their template, the class template, that's because it was after chapter 17. We didn't really need to know what it is, but now we know what a template is. We understand we don't need to declare a data type. It'll let us do one and go from there. We don't have time in this class to really get into the template library. But as you did queues, as you did stacks, you started to see some of what's going on there. Again, it's a generic data type. Wow, my bookmarker's been used pretty good here, hasn't it? Questions on anything you should have known coming into this class? Exceptions or templates? No, Professor, you're doing a great job today. Well, thank you. I'm hoping the snow melts so I don't have to go out and shovel. We only got about 2 inches here.
I hope I don't have to clean my car off because I hate doing that.
Me
As
too.
I've noticed as I got older, snow is just more of an inconvenience, and I hope every single time that they call for it that it doesn't happen.
So what you're saying is you have more and more responsibility and you have to like deal with cleaning your own car off. I know, right?
Or just having to trudge through the snow because it's like wet and it's cold.
Time to move. Time for me to head south as well. Second part today is going to be more lecture, and then I'm going to give you a program to do. The second part today is linked list, but something that we now use a phrase, a doubly linked list. A doubly linked list. You want more information? It's in NIOF 11.3. But what if we need to be able to work bi-directional? We want to go both directions. We want to be able to go forward and backwards. We want to go backwards to our, should have used pencil, predecessor, the one that comes before, or we want to go forward to the successor, the one that comes after. So in a doubly linked list, our node is now going to be a little bit different. Instead of just a next pointer, I'm going to have a prev pointer. And then I'm going to have, I don't know what all is in here. We've been doing these with a single piece of data. But remember, in this struct, I could have this pointer, and 8 pieces of data inside of there. This is the data type I'm creating, working with this type of node. A lot of times you'll see it horizontally. Sometimes you'll see it written vertically. Uh, Whatever floats your boat. So if I look at an example of a doubly linked list, I see one here. Yeah, I have a first, and the first is going to get me started. Chewbacca, I go here. Oh, remember this node is going to have a prev. Where does that go? It could go to null. It could go to out to make it circular. We saw that idea of circular. It could go all the way out to the end. Different usage of a doubly linked list, whatever is needed for you. I have pointers going forward. I have pointers coming backwards. At the end, I go to null or I go somewhere else, maybe to the beginning. So now a question comes, well, yeah, this first gets me started, but how could I go backwards? How do I get out here? Well, if I have a first pointer, what the heck? I might as well create a last pointer that points to my last node. If I append and add a node at the end, last, and this node goes there, then I just move last over. If I'm going backwards, if I delete this, what would last now be? My question is, if I deleted this node, last would now become, how do I get last to point here? Last would get the value of last prev. That would back me up one. Here's prev. Last would now get the value of this address. Nobody answered me, so I guess I'm okay. You got it? Yes, no, maybe. Okay. So if I get ready and take a look at this guy right here, and I have a first and a last in there, and I said, okay, I have to write the function for insert. For insert. Give me some test data. What could I possibly want to insert?
Ten.
And give me some more.
$11.
Uh, well, 10 and 11 are both going to be in the
Oh,
middle.
13.
13 still in the middle. How about 3? Why 3? It would be at the beginning of this list. What else?
7.
Yeah, 17. And then there's one more thing that might insert. What's the very first thing that I should be thinking about? Carl?
I was gonna say maybe if the list is empty.
Yeah, is empty. Good answer. So when I get ready to write this function, I need to make sure it works for all of my test data. If I wanted to delete from here, what would be some test data to delete? Carl, give me your answer again.
5.
Nope. What did you just answer last time?
What do you mean? Like is empty?
Yeah, this is empty. I can't delete anything if it's empty. You said 5, but I'm going to skip a line. What else might I try? 3. 5's deleting the first one. 8. 8 would be deleting something in the middle. I'm thinking 10. Make sure that would work. I'm thinking 15. And I'm thinking 17. Got my test data. If I had you write a program, yeah, and we did that, I believe, last class. I'm like, did you check all of your test data to make sure everything works? I'm trying to get you to think this way. Test data, test data. Now, when I get ready to run it, because we were in that big group project, and when I came in to see what was going on in those groups, it was like, okay, I have test data in mind. I know what I want to tell you to try and make your program bomb, because that's my job to make it not work, to make sure everything works. Draw the picture, draw the picture, draw the picture. Test data, test data. Now I'm thinking about how I need to attack this. Question. Is first, next, prev val. Let's take a guess. 5, 8, 12, 15, or no?
Is it 8?
It is 8. This is first, points to here. This guy is first, next. It's that address. This guy pointing out here would be first, next, next address. So now I'm pointing at this node. The prev brings me back here. That's the prev. So that would be first, next, next prev. And then there's the value is 8. Doubly linked list. Here we go. Let's start with, I have temp pointer pointing there to the 5, which means I just did some sort of traversal and check. And I found out that temp pointer's next value is greater than 7. I just found out that temp pointer's next value is greater than new node's value. So some sort of if. If this is true, that means I need to insert it. You jiggy with it? Four lines. 4 lines of code. So somehow or other, I need this to point to there, this to point to there, this to point up to here, and this to point down to there. 4 steps. Will the order matter? Absolutely. Absolutely.
We have to go backwards from 8 to 7.
Okay. So I'm going to number these or letter these. This is A, this is B, this is C, and this is D. So which order do you think we need to do first?
D.
D. So new node, you want D to go first. Okay. Then what?
C.
C. Okay. Well, let's just do those. B would be new nodes next. This would be new nodes next. All right. New nodes next. That's this guy. Gets the value of I want a point here. What point's here right now? This guy, right? This guy would be temp pointers next. All right, so now we just eliminated this guy. Well, no, we just created this guy. C would be what? C would be this line. This line's a handful. So this one's done. I want this to now
So
come
this line is okay. So I thought like this line is putting to 5, but it's putting down to the new node.
right because it's going to come before it. So what is this line right here? Right now it is temp pointers next prev. This guy is going to get the value of what do I want it to point to? Well, I want it to point here, right?
The new node.
New node. Very good. And I think I'm pretty good by doing those two lines in that order. That took care of this part. I now have a connection from 7 to 8. Okay. What's next? A or B?
A.
Go ahead. A says new nodes.
Is it new node next?
Uh, Not next. I'm going backwards.
Prev,
Yeah. Equals. Where do I want this to point?
temp pointer.
Excellent. B would be this guy pointing to here. This is
Temp pointer n next,
yep.
and then new node.
Yeah. Got it. If you got everything we just did, starting with the if statement, give yourself a pat in the back. I'm sure almost every one of you could have just coded this without drawing the picture first. Yeah, we could have. That's right. We're bad at it. Yeah,
I mean, probably, but seeing it for the first time, like, well, not for the first time, but like for the first few times, like as a drawing helps.
absolutely. Absolutely. Okay. I want to delete 8, right? Need a temp pointer. I have a value that equals 8. And if any node equals 8, I want to get rid of the node. Tell me what to do. I want to get rid of this. So this guy needs to point over to here. Okay. And this guy needs to point back to there. 2 lines. 30 seconds and thank on it. These are long lines. You got to move it down here. 1, 2. Um, Again, we're going to call this one A and this one B. Drawing the picture, I kind of get a pretty good idea. I don't think, since temp pointer is pointing here, I don't think the order's going to matter very much. So let's do one and say that's A. We're going to do A first and then B. Tell me something
You need
good about it. Go ahead.
you need A to point to or uh A's next to point to whatever 12 is.
So give me the code. Everything is going to be based off this temp pointer.
Oh,
What is this guy right now?
So like the previous,
first, I think. Wait,
Temp
is it?
pointers, previous, temp pointers,
Oh,
previous, that guy,
equals
not yet.
10 pointers next.
We're gonna be getting rid of this. This is the guy I'm looking for right
Mhm.
now. So this is temp pointers, prevs, next, right? This is the one we want to change.
It needs to be 10 pointers next.
Very good. Temp pointers next is this. It points to here. I want it to point to there. So temp pointers previous next now gets the value of temp pointers next. So we got the next one. Next one is changing this line to go to here. Right now, based off temp pointer, this line is temp pointers.
was it 10 pointers? Next, um, previous?
Yep. And I wanted to point to this node. Where is this node? Temp pointers.
10 pointers, next or previous?
Very good. I got a call. Awesome. Now, again, for the delete in a doubly linked list, there's going to be the whole how do I get here? The traversal to get there. And could a third step be this? Destroy temp pointer. Free up the memory. Absolutely. Questions, comments, complaints, anything good like that. Okay, here we go. You know, I prefer when you are typing, and you see that we now have a assignment that I want you to work on for the last 40 minutes of class. Doubly linked list, and you're going to see there's number list, number the spec file, the implementation file, and a demo. Well, the first thing I want you to do is go in and make this a doubly linked list. And while you're there, put in a rear pointer. Now, if that's all you get done today, then that's fine. That's a really good start. If you have more time, can you fix insert? Well, we should have an idea of what to do for insert. We just walked through it. Can you fix delete? Can you do a traversal starting at the rear? That would be a new function. I have in there, you can delete append node. You don't have to worry about that. Any questions? So there's the three files. And And let's see what we have here. So I said you can go through and do a couple of different things, but you're going to start with adding a prev. As I said, you can get rid of append. So what I would do is get rid of the append going. I would keep compiling every time I add something new. Because what's here actually should be working. And then I'm going to come in here and again get rid of append. But how will this work with display? Does display need to be changed? No.
Um,
Yeah,
Did
can
you
anyone
share?
else?
I
Did you
am
share a
so
Can
sorry.
screen?
anyone else?
Yep.
Yeah.
Yeah, that's me. Now,
Yes. Thank
I'm so
you.
sorry. So coming back in here, you're going to need to add a new line of code to have a prev. You're going to come down here, like I said, get rid of append. You don't need append. All right. You have a head. I would add a rear. This should still compile and be good and happy. Then I would come in here and like I said, I would get rid of append. We don't need it. Why have extra in here right now? I would then fix up display. I don't know that I need to fix up display. Could I simply change the, well, we have to add some things first. Could I copy this and do display list reverse and just start instead of head, I would put last, maybe change head to front since we're doing fronts and last. I think I learned how to do that. Edit, replace in files. Can I replace the word head with front? And again, what I'm in, whatchamacallit, Dev C++. And it goes through and replaces them all. It's kind of nice. Yeah, I actually now have it listed as front. Yada, 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 yada. And then mess around with the pens, see what happens, see if you can get delete. Start to play around with working with doubly linked lists.